Hey, Ryan.
How you doing?
I'm doing okay. So everything normal back at school? They all done with the TCAPs?
Yep. Yep.
How were those tests? Were those similar to the CSAPs?
Yeah, they're the exact same.
Uh-huh.
What they're doing differently. But,
Okay. So what are we going to do today?
if we go to that website you have bookmarked,
Okay.
should only be. There's two things that we've learned new, and it's chapter 11.2 and 11.3. And I'm not understanding it much at all.
All right. Surface area is the outside area.
Right.
Okay. Now, a cylinder, if you were to think of this cylinder trying to figure out the best way to explain this. If you were to take a dollar bill and roll it up so that the ends touch one another, it's in the shape of a cylinder, right?
Yep.
So the surface area of that cylinder would be if you unrolled the thing. In other words, if I took this and unrolled it, unwrapped it, let's say this was like a can of soup, and you had a soup label on there.
Yeah.
And if you peel the label off the can and lay it out flat on the table, it's going to be a rectangle.
Right.
Okay, and in this case, the height of this rectangle is going to be 7.2. What is this measurement from here to here?
8 meters?
No, that's the diameter of that circle. This measurement from here to here actually represents the circumference of that circle. Notice that our dollar bill was rolled up end so that this left end was touching this right end perfectly.
Right.
So when it was rolled up, this circular was the length from here to here. So what we want is the circumference of that circle. What is the circumference of that circle?
So it'd be 16 pi.
Good. And that's pi r squared. Circumference is what? Circumference
2 pi
is
r.
2 pi r.
Okay, so it's going to be 8.
Right.
No, yeah.
That's
16.
correct. 8 pi. Because the circumference is 4. So the dimensions of this right there are 57.6 pi. That's just the label. Now let's examine whether we have a top and a bottom on this thing. Well, I guess we do have a top and a bottom. They've got the 57.6 pi answer there. But if we, what's the area of the top? Can you tell whether they want the top and the bottom also? I'm having a hard time telling.
They would have to show it, wouldn't they?
I would think. However, let's see if that answer is on there. So what's the area of the top?
How would you find that? It would have just
Pi r squared.
so.
So
Okay,
this
so
top circle?
it'd be 64 pi.
Well, it would be half again because the radius is only 4.
Radius.
So it'd be 16 pi. And then if the bottom was included, it'd be another 16 pi. So that'd be 32 pi if they wanted us to include it. Now, the question is that answer on there? Yes, it is, 89.6 pi. So it's either this answer or this answer, depending on whether we should include the top or not. And I can't really tell from that drawing whether we're supposed to include the top. So what do you think?
I think if the answer's on there, then it has to be.
Both of them are on there.
Right, but if the answer to adding the top is on there, then it's probably...
We'll go with that one. We'll see when we get done. Usually when they're talking surface area, they're talking the entire surface. The only way that we would not include the top and the bottom would be if it was like an empty hat box. If it really was like a dollar bill wrapped up and there was no top and no bottom. But you generally don't talk about that. You can have an open box with a bottom, but I can't imagine a thing that wouldn't have a top or a bottom. So the more I think about that, the more that's correct. Okay. Use a net to find the surface area of the prism. Kind of a net. A butterfly net?
I have no idea.
Use a net. Did I miss something here in the terminology? All right. We can find the area of this prism. I'm not sure what they mean by using a net. How many triangles are there?
2, 4, 5. Or no. 4.
The only one I see is this side one and this side one over here.
I guess I counted the back one and the...
Well, that back one's a rectangle.
Yeah.
And the base is a rectangle. And this slanted surface is a rectangle. So let's just talk about the two triangles. What's the area of each triangle?
12 times 9. What is that? Divided by 2. 54.
So there's two of them, so it's 108. Notice I've got the area of 2, and this is supposed to be a triangle here.
Right.
Okay, so now, and that was 17. What is the area of this slanted face that is not perpendicular or parallel to the table?
15 times 12 it looks like.
The length looks to be 17. This 12 applies to that depth of that triangle. That 9 applies to the height. This 17 is this measurement, and this 15 is that lateral distance. Notice that is a 3, 4, 5 triangle. Okay, so this one then has to be 15 times 17.
Oh, 15 times 17?
Mm-hmm.
That's
Excuse me.
255.
Excuse me. Yeah, 15 times 17. In other words, if I were to draw out that thing, this is the 17 and this is the 15. I'm talking about the steep face here that's at the angle.
Right, right. But doesn't the 9 represent the...
That'll come into play when we look at this back triangle, or this back rectangle.
Okay.
And the 12 will come into play when we look at this base rectangle. And that's the only other two surfaces we have. We've got this face, which is 15 by 17. And what is that? That is 170 plus half of 170, 85, so that must be 255. Okay. Okay, so we have this back. There's only two more faces, right? That's this back one and this bottom one. So the area of, we'll call that the front face, is equal to 255. And what's the area of this back rectangle?
So that would be 9 times 17.
Right.
That'd be 153.
And then finally the area of the bottom rectangle.
So you do 17 times 12, right?
Right.
It'd be 204.
Add everything up, you got the total surface area.
Alright, 108, 255, 153, 204, 720.
Use a net. What could they have possibly meant there? Use a net.
I haven't heard of that.
No, I haven't either. Find the surface area of the cylinder to the nearest whole number. Once again, let's talk about the curved outside face.
Alright.
What are that dimensions when it gets unrolled? Remember, it unrolls as a rectangle.
Right.
What's the height of this rectangle going to be?
5.4.
And what's the distance, the length going to be?
Shoot, I have to figure that out. I don't remember.
Remember, it's the circumference of the circle. So what's the circumference? Right. So the circumference of the circle. No, that's the area.
2 pi r.
Okay.
So 6 pi.
Right. So that's this dimension right there. That is the circumference of that circle, is 6 pi. So this is what? 32.4 pi. Okay, and then we have a circular top and a circular base. It's the area of the circular top.
That would be pi r squared, right?
Well, okay, so it's 9 pi.
Yeah.
And this one's 9 pi. Okay, so what's the total surface area? Ooh.
Would you include pi, or would that make it pi cubed?
No, we're adding, first of all, so we're going to add 32.4 pi to 18 pi, and we're going to get 50.4 pi. Notice all of our answers do not have a pi in there, so which is the correct answer? What is 50.4 pi approximately? Pi being 3.14.
It'd be 158.
Has to be. I don't really like giving you answers like this. I prefer answers in pi, but I guess they were trying to trick us. Okay, let's look at this prism. This is pretty straightforward. This is a piece of board. How many faces are we going to have on this piece of board?
6.
Right. You can see 3. There's a unique face, there's a unique face, and there's a unique face. And every piece of board has an opposite side that's the same.
Right.
So we're going to figure out the surface area of this, this, and this, and multiply it by 2.
All right.
So let's talk about this one here. We'll talk about the area of the small rectangle.
Okay. So you do 7 times, is that 1.38?
Yes.
All right. And then you get 966.
Okay, let's go ahead and find out the area of each one, and then we'll multiply it by 2 and we're done. So,
Hey, hold on one sec. Someone's at my door. I've got to see who's here.
okay.
Hi. I'm in the middle of a tutor session. That's okay. Just get back to your dad. All right. Talk to you later. Bye. Sorry about that.
It's all right.
All right.
Okay, so we've got the small rectangle was this one.
Yep.
This I'm going to call the middle rectangle.
And we get 12.42.
And that's 9 times 1.38.
Yep.
And then we got the big rectangle.
So would that be 7 times 9?
63. Add those 3 numbers together and multiply by 2, which notice is slightly more efficient than multiplying each one by 2 and adding the 3 numbers.
Right.
There's more steps that you have to take if you multiply by 2 early.
You get 170.18.
After you add them and multiply by 2,
Yep.
what do you get?
170.18.
Okay, or 170.16 probably. Okay. Interesting that there was that much round-off error. Because I see 0.18 also. Because this 7 and 2 adds to 9, and multiply by 2, you get 18. Wonder how they got 0.16. Did you round off before? You probably did, didn't you? Yeah. In other words, they probably carried out. No, if there were more digits on here, it would be less likely for that thing to get down to 0.16. Okay. Not important. I'm just curious. Use the formula to find the lateral area and the surface area of the prism. Show your answer to the nearest hundredth. Okay, what's the difference between the lateral area and the surface area?
I'm not sure.
The lateral area is the area between the 2 parallel sides. In other words, something is a prism if it has a face that's parallel to an opposite face.
All right.
And then it's connected at each vertex. So this is a prism. And the lateral area is all of the surface area not counting the 2 end pieces.
All right.
Okay, so let's first of all find the lateral area. And the lateral area has how many faces?
2.
Look again.
2 7.
Here's one, the slanted one. Here's another, the bottom. And here's a third, the back. In other words, the 3 sides of this triangle, each connecting to the 3 sides of this triangle over here, each one of these becomes a face. That's a face, the bottom is a face, and then the hypotenuse connecting with this hypotenuse is a third face. So the lateral area equals the, we could call it the area of the hypotenuse rectangle What's that?
Of the hypotenuse rectangle. I guess I'm still not seeing it.
Okay, see the hypotenuse of this triangle?
Yeah.
That is the left edge of that top face.
Right.
What's the area of that?
6 squared plus 9 squared.
Well, they already give it to you over here. 10.82 is the lateral distance.
Alright, so 10.82
times
2.
times 21. In other words, here's the, let's make sure you're seeing this rectangle. Here's the 21, and
Okay.
here's the 10.82.
Alright.
So the area is base times height. What's 10.82 times 21?
Uh, 227.22.
Now, can you see that that's the only rectangle with those dimensions in this prism? This is not equilateral. In other words, this doesn't have an equal and opposite backside to it.
Alright.
There's two other faces. There is the area of the base rectangle. We'll call that the base rectangle, and the area of the side rectangle. So what are the dimensions on the base rectangle, this bottom one, denoted by the dotted line as its other edge?
9 and 21.
What's that area?
189.
And finally, we have this back rectangle. What's its dimensions?
6 and 21.
Okay, what's that?
Well, 126.
Okay. So the lateral area is 227 plus 189 plus 126.
And that is 542.2.
Okay. Now, what do we have to add to that to get the total surface area? Not that we have to do it, because they only gave us one answer, but let's do it anyway. In other words, what's the area of this rectangle, and there's two of those? That's the only thing in this figure that there are two of.
The triangles themselves?
Uh-huh. There's the front one, and then there's the back one.
Oh, okay. So you get 54 plus, what would that be?
Well,
No,
it's not
454.
54 is both of them combined, because this is going to be 1/2 the base times the height.
Oh, that's right.
So that's half of 54, but we have another one, so a total of 54. So the first answer has to be 542. The second total surface area has to be 54 greater.
Right.
Okay. And you wanted to go over 11.3 also?
Yeah, and then on Wednesday I'll have 11.4 and 11.5.
Okay. Now this one is surface area and volume. Notice the difference. Surface area is outside area. It's 2 dimensions. Volume is how much liquid that could hold. In other words, it's the dimension 3 dimensions. So surface area is going to be square centimeters. Volume is going to be cubic, whatever our thing is. So the surface area of the cone, in terms of pi, how do we figure the surface area of a cone? What's the formula for that?
I don't know that.
Has to do with this lateral distance. In other words, if we know the lateral distance of a cone, That's what we need. It's called lambda. We need that lateral distance. So, what is that lateral distance?
24.
No, the vertical height is 24. So you have a triangle that's a 2410. So use the Pythagorean theorem to figure out the right side of that triangle.
Okay. So, 24 squared minus 10 squared equals 20. So it's 21.187.
It's how much?
21.817.
Okay. Now I know that can't be right. Why is it that I know that can't be right?
I don't know.
Because the hypotenuse has to be the largest side of a triangle.
Oh, okay.
So we've done something wrong.
You do 24 squared minus 10 squared, right?
No. You have the two sides of the triangle, so the hypotenuse is the square root of the sum of the squares.
And that's 26.
Okay, that makes more sense. 26 exactly?
Yes.
Okay. So the surface area of a cone is the base, which is pi r squared, this part here, plus pi r L, where L is the lateral surface area.
All right, so...
So what's the radius? 10. So it's 100 pi for the base.
Plus pi 10, and then 26.
Okay, so that looks like 260 pi.
All right. How would that get 260? Looks like a...
Well, it's 10 times, it's the radius. The radius is 10. That's pi, and this is 26. So 10 times 26 is 260.
Oh.
So this would be 100 pi for the base plus 260 pi for the lateral area.
It'd be none of those because there isn't a 360.
It's the first time I've ever seen that be the correct answer. Surface area of a regular pyramid. It's actually the same formula, only applied differently. The surface of this pyramid is going to be pi times the side squared. In other words, it's the area of the base, which is one side squared. Instead of the radius squared, we're squaring the base. So, and it's not pi, it's just 4.
Right.
Plus the lateral surface area is very similar to this definition here. This was pi RL. Well, this is going to be 1/2 the perimeter times L.
All right.
instead of the radius. Well, it seems like P, I would have thought P should be the distance from the center to the edge, like 1 in this case. Would have made more sense. Okay. So the perimeter is what?
4.
And the lateral area?
Lateral area.
Not the lateral area, the lateral measurement?
8.
Okay. So it's 2 times 8, 16.
Oh, no, the perimeter would have been 6.
8.
8, I'm sorry.
So it'd be 4 times 8, 32. So 36 is the answer.
Yeah.
Okay. Good example of when you don't see the answer on there that you're expecting. Usually means we've made a mistake, a simple mistake somewhere along the line. Okay, find the lateral area and the surface area of the cone. Use 3.14 for pi and round it off. Let's do the lateral area first. What's the formula for lateral area for a cone?
To find the hypotenuse.
The lateral area is pi RL. The surface area is the lateral area plus the area of the base. So the surface area is the area of the base, which is pi r squared, plus pi RL. So there's your two formulas. What do we know? We know R and we know L. That's all we need. So what's lateral area going to be?
Alright, so 10 pi 22.
Go ahead and let's get a number for that using 3.14.
Alright, so we got 3.14 times 10 times 22. That gives you 690.8.
Okay, now we can't immediately answer this because there's a none of these. At least they were a little smarter here. Okay, so now let's add pi r squared to that.
Alright.
That's 100 pi. We don't need a calculator for 100 pi. That's 314.
But then you have to add in 3.14 for pi, don't you?
I did. I multiplied 100 times 3.14 and got 314.
Alright.
So the total area has to be this one here, 104.
Yeah.
So the lateral area is 690.8. Surface area, the total surface area is 104.8.
Alright.
Actually, it's kind of amazing how much of the surface area is the base. Okay. Find the value of x, the slant height. Excuse me, that's what I should have been calling it all this time. It's called L is the slant height. Round your answer to the nearest hundredth if necessary. This is actually a fairly easy geometry problem. It's all in looking at it from the right plane. So you see the triangle that's designated by that middle dark line going to the center of the base?
Yeah.
That's this line here. X is this line here.
Okay.
And what is this distance from here to there? It's going from the center of that square to the edge.
Oh, it'd be half of 9 then, so 4.5.
Now we can figure out x, because this is a right triangle.
Okay, so 4.5 squared plus 9 squared, square root it.
It's got to be 10.06, isn't it?
Yep.
Okay. Find the surface area of the cone in terms of pi. What's the lateral area of a cone equal to?
It was pi r
Slant height. Pi r slant height.
Okay.
Okay. And then the base, the surface area, is the base, which is pi r squared plus the lateral area.
Right.
Okay. Here they want the total surface area. So what's the pi r squared?
Pi r squared would be 9 pi.
What's this measurement?
5.
Okay, so that's going to be 15 pi, because r is 3, and that's 5. So that would be 15 pi. So 24 pi. You want to get a head start on your Wednesday material?
Well, I'm worried if I do that, then I won't have anything for Wednesday.
Okay.
Since we haven't
That's
learned
fine.
it. Like, it's helpful learning it and hearing it from 2 perspectives.
Mm-hmm.
And usually on a Wednesday Access, I go in and see a different math teacher.
Okay.
So I can hear from a couple
Okay.
different forms.
Well, we've still done nothing but surface areas. We haven't done any volumes yet.
All right.
The rest of this must be volumes. In other words, I'm thinking 11.4 through 11.7 is probably volumes, and that's probably what we'll work on Wednesday.
All right. And then over spring break, I will not be there.
Okay, tell me when that is. And
It'll be next week, next Monday and next Wednesday. 22nd is Friday.
So your spring break is the week before Easter?
Yeah.
So I've got the 25th is Monday, so we want to cancel this one.
Yep. And same with
And the same on the Wednesday. But you want to keep your 2 appointments
after spring break.
after spring break.
As well as the one right after Easter, Monday. We don't have school then either, so I won't have anything.
So cancel this one on April 1st.
Yes.
Okay.
And we head back Tuesday, so.
Cool. Okay, so I will talk to you on Wednesday of this week. Let's see. 18th. Okay, that's this calendar here. Yeah. All right.
All right.
Anything?
Thank you so much.
Okay, so I'll just talk to you on Wednesday.
Yep.
Okay. Bye-bye, Ryan.
Bye.